Hey guys, Dr. White here from the Ultimate Science course. Hey, I just wanted to give you some teaching tips for teaching hybridization. Hybridization is one of those subjects that traditionally is a little bit difficult, conceptually difficult for the students to get, and I wanted to give you some teaching tips that I use with my kids. The first teaching tip is that hybridization is a modification of the existing atomic orbital model, right? So we learn all about atomic orbitals, right? The S, the P, the D, right? Those are true for atoms, right? But we're trying to change the picture to explain the shapes of molecules. So typically we talk about hybridization after we go into VSEPR, right? We're changing the model so that the students can understand how the electrons that were in these S and P orbitals are now arranged around the central atom so that they can make, say, a tetrahedral methane molecule. Okay, so it's also a really great opportunity to talk about the fact that theories can change and modify over time, right? That's one of the beautiful things about science. Second thing is crucial when you're teaching hybridization, you have to show them the orbital box diagrams. The students need to see the S and P. Let's say we're talking about carbon, right? You've got the 2S and the 2P, and you show those on the piece of paper, right? But then you need to show the modification of that orbital box diagram in the atomic frame to the orbital box diagram in the molecular frame, right? And then typically the way I do it is I draw the S and P orbitals and I fill in the boxes with the electrons. And then I show the promotion of the 2s electron, if we're talking about carbon, the promotion of the 2s electron to the 2p. And then I show the hybridization where we merge the s and the p orbitals to make the new sp3 orbitals if we're talking about methane. Now, a lot of students, I always get questions, well, where does the energy come from to make that electron jump from the lower energy 2s to the higher energy 2p? And that's a good time to talk about the fact that when you bring hydrogens into the picture, or any atom that's going to be bonding around the center atom in a molecule, you're changing the energetics of the orbitals, right? So you're accounting for the fact that the energetics of the orbitals are changing. We're changing to the sp3, and that gives the electrons new energies that they can jump into and rearrange. Last thing, I always am really clear when I show the shapes of the orbitals. They need to see the spherical S and the P change into this lopsided dumbbell that is typically an SP or SP2 or SP3 orbital. They need to see that, and then you need to explain that the fact that it's lopsided is very important, because if it wasn't lopsided, the electrons wouldn't spend most of their time on one side of the atom, which is the bonding side of the atom. If the electron's on the other side of the atom, which is the little part of the lopsided orbital, if it's on the other side of the atom, then it's not going to be doing any good for the bonding. So it's super important to show the lopsided nature of the new hybridized orbital. So I'm including in the email I'm including with the video a link to the activity that I use with my kids. It has the kids think about, it goes from methane to ethane to ethene to ethine, right? And then this shows this this evolution of the hybridization, and then it also shows how the p orbitals come together to make pi bonds. So hopefully that helps. I hope you guys have a great time teaching hybridization and bonding.